video is about evaluating nth roots and rational exponent notation. So if the instructions ask you to find the indicated nth roots of a, and then they give you an n and they give you an a, they're asking you just to evaluate a root. A root could be a square root, a cube root, a fourth root, a fifth root. Whatever the indicated n value is tells you what kind of root you're taking. So if n is 3 and a is negative 216, it's asking us to find the third root, or the cube root, of negative 216. It is possible to take the cube root of a negative number, because you're looking for what number times itself 3 times would give you negative 216. And sure enough, that's going to be a negative number. So it's not imaginary, and it certainly is possible. So for this one, we're looking for the number that multiplies by itself to make negative 216 if it's multiplied by itself 3 times. And the answer that we're looking for is negative 6. Negative 6 times negative 6 times negative 6 would give us 216 negative. So that's the cube root of negative 216. In this problem, we're looking for the fourth root of 81. So what number, when multiplied by itself 4 times, gives us 81? And because this is an even root, right, the number 4 is even, we have to consider that you may have positive or negative answers, because a positive times a positive would give you a positive, but a negative times a negative would also give you a positive. So you're looking for a plus minus in front of any even root. So this time we're looking for plus minus, and then the number that multiplies by itself 4 times to give 81 is 3. So remember to put a plus minus in front of even roots, whereas an odd root would either be negative or positive, not both. We can use that, apply that in an equation that says solve for x. We're going to divide by 4 on both sides and find that x to the 5th power equals 32. And then we can use a root to solve this equation. So if we're trying to get rid of the 5th power, we will take a 5th root. So I take a 5th root on both sides. And this is an odd root, so I'm either looking for a positive answer or a negative answer, not both. I'm looking for the number that multiplies by itself 5 times to make 32, which is positive 2. Similarly here, if the entire expression in parentheses is being raised to the 4th power, we want to start by taking the power, or getting rid of the power by taking the root. So we're going to take the 4th root of both sides. And what's left on the left side of the equation is just x minus 3, because the 4th root and the 4th power would cancel out. But on the right side of the equation, we have to remember that this could be positive or negative 3. And now we actually have to separate this and solve this as 2 separate equations. It's x minus 3 equals positive 3, and x minus 3 equals negative 3. Solve both equations, and both of them are acceptable answers. Another way to write a root or a radical is to use rational exponents. So this is the second part of the video about rational exponent notation. So the word rational means a fraction, right? Can be written as a fraction. And you may never have seen a fraction written as an exponent before. What they mean is the same thing as a square root or a cube root or a third root. It's just another way of writing it. I want to show you why this works. So we're going to start just by reviewing the basic rule of exponents, in case it's been a while since you've done this. If you have x to the 2nd power times x to the 3rd power, you add the 2 exponents together and it equals x to the 5th power. So it's going to be an important rule when we're talking about exponents here to remember. Completely separate from that, I want you to see that this is also true. When you have the square root of x and you multiply it by the square root of x, you should know that this is just going to equal x, right? The square roots would cancel each other out, in effect, because it becomes the square root of x squared, right? So the square roots and squared would cancel out, and you'd be left with x. So we're going to put these 2 properties together here. The first one I showed you about exponents, and then this property about square roots. So you can see how exponents can be used to write roots. If I write x to the 1/2 power multiplied by x to the 1/2 power, and I follow this rule, when you multiply 2 powers together that have the same base, add the exponents. 1/2 plus 1/2 equals 1. So this would just equal plain old x to the 1 power, or x. And then if you look at these 2 statements taken together here, square root of x times the square root of x equals x. X to the 1/2 times x to the 1/2 equals x. Well, then it must be true that these 2 statements are equivalent to each other. And so it's true to rewrite the square root of x as x to the 1/2 power. These two things mean the same thing. Square root of x is the same as x to the 1/2 power. So you can write a root, like the note says at the top, you can write a root using a rational exponent, right? You can write a square root using the exponent 1/2. So what about other kinds of roots? Well, if you have a cube root or a third root, it would equal x to the 1/3 power. If you have a fourth root, it would equal x to the 1/4 power. I think you can see where this is going. The denominator of each of those fractions is the root, right? So the root becomes the denominator. And then, obviously not every fraction has 1 on the top. So what if the exponent here, instead of saying 1/4, said 3/4 or 5/4? You could have another fraction as your exponent. And what would that mean? Well, what that would mean is, let's say you had the fourth root of x, and x was being raised to the 3rd power. So we've got a root, and we have an exponent in our original statement. Then, when we convert it to being a fractional exponent, that 3 becomes your numerator. It's just a normal exponent, and the root still becomes the denominator. So if you have a fraction with something other than 1 as your exponent, what that means is that there was an exponent in the original problem to begin with. So if it was, for example, the 5th root of x to the 2nd power, we would write that as x to the 2nd power over 5, right? So x to the 2/5 power. You may also see it written this way, with the 5th root and an exponent on the outside. I used the same numbers as the example I just did because it actually is equivalent. It means the same thing. Whether the exponent 2 is inside or outside, it's an exponent on the whole expression. And so it means the same thing. Okay, so this might be brand new to you, but all we're going to practice at first is flipping back and forth between the two forms so you can see that they can be used interchangeably. To evaluate one of these without using a calculator, then, we just want to write it as a root so we can see what root we're looking for. So in this first one, it's 4 to the 5/2 power. Remember, the denominator is becoming the root. So if the denominator is 2, we're looking for a square root, and inside we have a big 4. Now that 5, that was the numerator of our fraction, we have the option of either writing it inside or outside of the expression. I think it's going to be easier here if we write it on the outside, because we know what the square root of 4 is. The square root of 4 is 2, and then we can easily do 2 to the 5th power, right? This is 2 to the 5th power, and so we can easily do that and get 32 as our answer without using a calculator. On this next one, it also asks us to remember what a negative exponent means. Negative exponents mean flip it, right? It does not mean that the answer will be negative. It means flip it. The answer will be a fraction. So this is the same as saying 1 over 9 to the 1/2 power. We know that that 1/2 power means the square root, right? Because the denominator becomes the root. So this is like saying 1 over square root of 9. And we know the square root of 9 is 3. 81 to the 3/4 power, denominator becomes the root. 81 goes inside. We have the 3rd power outside. Easier again to put it outside because we know the 4th root of 81. So we'll take the 4th root of 81. We'll use the positive 4th root here because there is no plus or minus in front of this. So we'll use the positive 4th root of 81, which is 3, and then 3 to the 3rd power, which is 27. And then 1 to the 7/8. We're going to use 8 as our root, 1 on the inside to the 7th power. But it almost doesn't matter what these numbers are because any root of 1 is going to be 1, and then 1 to any power is going to be 1 as well. And then this is just practice flipping back and forth between the two forms. So if it says rewrite using radical notation, we want to take it from this and write it using radical notation, even if it's something that you can't evaluate, and you would just leave it like this. The next one is, remember, if negative exponent means flip it, make your exponent positive, and then rewrite it in radical notation. So the cubed root of 64 to the 2nd power. Or remember, you could write it as the cubed root of 64 to the 2nd power with the 2nd power inside. You have the option of putting that 2nd power outside or inside. Either answer is acceptable. And if it says rewrite using rational exponent notation or rational exponential notation, We're going to take it from radical form and write it with a fraction as an exponent instead. And just remember the denominator becomes the root, or the root becomes the denominator. The exponent stays as the numerator. So the exponent is a 5, that's our numerator, and the root is a 4, that's our denominator. We have a negative 30 as the base, 2 is our numerator, and 3 is our denominator. And that is all.